make sure that you know which factors to look for first.
For 8, he used -2/3 and he used long division. So he just used.
Right. So you can only, this is the only real root. The other two, I'm sorry, this is the only rational root. The other two are irrational. And again, that's why I'm like not sure how you would know that off the top of your head.
Yeah.
But that's okay. So let's go back to this, kind of like you have in the previous problem. I actually really like how neat your handwriting is. We're gonna put the -2/3 in the box here. Sorry for all the scrolling. And then you bring down all the coefficients. So 3, 2, -3, -2, -6, -4. And you bring these down and you should get 0 at the end. Like that's what you're hoping for. Okay.
Yeah.
So 3 down, take the 3 and multiply it by 2/3. That's -2. You add 0 times -2/3 is 0. Add again. -3 times -2/3 ends up being +2. Gets you 0 here. And then 0 here, bring down the -6. 2/3 of -6 is 4, and you get the 0 as expected. You should get a remainder equal to 0 if it works.
Okay.
Okay. So this was x to the 5th, x to the 4th, x cubed, x squared, and so on. The new line here is 3x to the 4th minus 3x squared. Notice how it goes down by a power of 1 each time. 5 goes to 4, the 3 goes to a 2, minus 6 equals 0.
Yeah.
Is that okay?
Mm-hmm.
So at first glance, maybe you're not sure that you can factor this. You always try a GCF of 3 here. So you have x to the 4th minus x squared minus 2. The inside part does factor. So you're looking for two numbers that multiply to -2, but add to -1. That's -2 plus 1, like that. And then you set each of the new factors equal to 0. Okay. The ones on the right here, these give you complex roots, which I don't know if you're doing. I'm not sure. I don't think you are based on where you are in the course, but could be wrong. This one on the right does, on the left does work out. You get x squared equals 2, moving that 2 over. Then you take the square root of both sides. So x equals plus or minus the square root of 2. So if you go back to Desmos, if you did graph this, these are the plus or minus 1.414 that you're seeing there.
Okay.
Any questions on that?
Okay, hold on. Let me just finish copying this down.
Sure. Yeah, there's a lot here.
In the solution, he just had negative square root of 2, positive square root of 2, and -2/3.
That's right. So the first root -2/3 comes from the graph here, and then us verifying it in the synthetic division. Let me actually see. It says find all real zeros. Yeah, so your real zeros, you're looking for a list here. Your real zeros or your roots are, like you just said, -2/3, positive square root of 2, minus square root of 2.
Yeah. Okay.
All right, we can move on to number 9.
Mm-hmm.
You ready for that? Write a polynomial function with real coefficients for a degree 3 polynomial with zeros that include 1 plus I and -3. So this 1 plus I, the complex roots, this is a complex root, they always come in pairs. They're called conjugate pairs. Maybe you heard that in class. And they always change the operator in the middle. That's the conjugate pair right here. Like if it's 1 plus I, it becomes 1 minus I. If you get another one that's like 2 plus I, it'd be 2 minus I.
Okay.
The same is true for roots. Roots also come in pairs. Okay. So the way you write your polynomial in factored form, you have a leading coefficient A, and then it's x minus your 0, x minus your 0, x minus your 0. So for the real one, it's not too bad. It's like, okay, well, it's x minus a minus 3. For the complex ones, you actually treat them like they're in parentheses. So it's x minus 1 plus I, x minus 1 minus I, like that. Is that okay how we've written it so far? There's more to do, but this is the setup.
Yeah. Yeah, that works.
Okay, so a little more to do here. On the first factor here, it's going to become x plus 3. The second factor, you distribute that negative to both. So x minus 1 minus I. And then the third one, same thing, x minus 1 plus I, like that. So combining the negatives, distributing the negatives, kind of a rewrite step here. Now your focus should be on this right here moving forward. Okay, you always multiply the complex factors first. Right, and the reason is the I should cancel if if you multiply it right. Okay. So we're going to take this x and multiply it by everything in the one on the right. And then you do the same thing with the minus 1 times everything on the right, multiply the minus I times everything on the right. So that becomes x squared minus x plus xi. Now we're going to take this minus 1 and multiply by everything on the right here. Now my preference is to line them up vertically when they match up. So minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. That's a new column. Minus 1 times I is minus I, like that. And then we're going to do the same thing for the I here, minus I times x minus xi. Minus I times minus 1 is plus I. Minus I times plus I is minus I squared. Maybe this looks disconnected, but what happens is if you add vertically, you can see that you get a bunch of cancellations. The xi cancels with the minus xi, the minus I cancels the I. So you have plus 1 minus I squared. And you might think, okay, well, I thought you said all the i's were going to cancel. Well, they do. I squared is -1.
Okay.
So we have to put that in here. So it's minus a minus 1. Okay. So it becomes x squared minus 2x plus 2. And that represents all the stuff in green that I highlighted up there. So I'll just highlight it here. You take a deep breath. You're like, wow, am I done? Nope. A little more to do. You have this x plus 3 here. A on the outside. And it doesn't say it though. It should say write a polynomial in standard form. I mean, that's why we're doing this multiplication. I mean, I probably should have asked, but I'm assuming your final answer is like an x cubed plus something x squared plus something x plus something like, then that comes from multiplying all this together.
Okay.
Can you check? Do you mind? Because I don't want to spend time on.
That's it.
Okay, fantastic. So same thing here. You take that x and you multiply by everything. So that's,
and just the x, you don't like multiply the 3.
you do, but you do everything by X to like consume the X, and then you do everything by 3 to consume the 3.
Okay.
So yeah, so you're ahead of me in terms of this. 3x squared minus 6x plus 6. I always line them up this way. A lot of students like to write them out horizontally. That's fine too. You find what works for you. So it's x cubed plus x squared minus 4x plus 6 times a. It says real coefficients in the problem. So either you're going to be given an a value or you'll have to calculate an a value. You could make a 1 and then you don't have to do anything because 1 times anything is itself.
Yeah.
Yeah, that's it. It is super hard to do these right the first time. There's just so much going on with the FOILs and the multiplication between
Yeah.
steps. So just if you have time, I'd recommend practicing that for sure.
Okay.
So, all right. Well, 10 is a lot like 9. Ugh. All right. I assume you want us to go in order here.
Probably.
Okay. Did you get anything else down for number 9? Sorry, I didn't mean to move
Yeah,
fast.
I did. I did, yeah.
You're good. I'm sorry. I didn't catch
Yeah,
that.
I'm good.
Okay. Yeah, just let me know if you need some more time. I'm very bad about moving ahead too quickly. All right, degree 4 polynomial. That's good. That means there's four roots, 4 zeros. They're giving you one of them, they're giving you another, but they always come in pairs. That means that 2i also comes with minus
Negative.
2i. You got it. Same thing with the other one. All right, so this corresponds to x minus 2i. This one corresponds to x plus 2i. Same thing with the minus 5i, comes in a pair, x plus 5i, x minus 5i, and you need to multiply all of these together here. So why don't you try doing this first one, and I'll confirm. If you have questions, you can ask, and then I'll do the other one here on the right.
I got x squared plus 4.
That is correct. Very
Okay.
good. The one on the right is x squared plus 25. If you stare at them long enough, you'll see a pattern there, maybe. It's not necessary, but it'd be good to maybe know that to save some time. We're not done though. You have to foil these. Do you want to do that for us too?
Sure. Is it x to the fourth power plus 29x squared plus 100?
Yes. And kind of like the last problem, you can let a equal 1, and then you've got your final answer. Some instructors give you a point on the curve, and then you have to solve for a by using that point. We don't have to cover that unless you think that that could be on there.
It doesn't look like it.
I would agree. All right. Ready to move on to 11? Okay, so you're supposed to write out all the possible rational roots. So the whole P and Q thing, but do you know if your instructor actually wants you to do that, write out all the possible roots, or just find them? You know, how much work do you have to show here for this?
He said to write them out. Like in his solution, he just wrote the P over Q.
Okay, so P over Q, P is 6, so roots 1, 2, 3, and 6. Q is 4, that's 1, 2, and 4. This was incredibly useful when we didn't have calculators and computers, and you could actually get something, get a root here by doing this. But now, I mean, we have Desmos calculators, just doesn't make sense, but that's why you're doing it here. So it's plus or minus, and we're going to take this 1 over each of these. So that's 1 over 1 is 1, 1 over 2 is 1/2, 1 over 4 is 1/4, and then 2 over 1 is 2. When you get to the 2 over 2, you already have that, so you don't rewrite it. 2 over 4 is 1/2, you already have that, so you don't rewrite it. 3 over 1, which is 3. 3 over 2 is new. 3 over 4 is new. 6 over 1 is 6. 6 over 2 is 3, which we already have. 6 over 4 is 3 over 2, which we already have. So there's your list. And so you would want to try them. Like if you didn't have access to Desmos, you would have to just basically guess until you found the right one. But since we have technology, we don't have to do that, right? You said you're allowed to go there and graph it. This is 3/4. Now, the reason this is so important is because it's a cubic. If you find just one root, it drops it down to a quadratic. And you know how to solve every quadratic ever. Like there's no quadratic you can't solve. So that's the whole power of this. It's like once you find that one root using your synthetic division, you can then use some other approach to find the others. So we're really hoping there's a 0 here on the lower right. Drop the 4 down. 4 times 3/4 is 3. Minus 8. This is minus 6, which is 8. 3/4 of 8 is 6. And there it is. Okay. So when it says find all real and non-real solutions, we have found the real one. It is 3/4. This is now 4x squared because it was x cubed minus 8x plus 8. And you now have to use one of the many, many other methods you have for solving quadratics. Since they're not listed on the graph, that tells you that it's going to be quadratic formula, almost certainly, because they're complex roots. This is the only one that was visible on the graph.
Yeah.
All right, now to make this a little bit better, you should factor out the 4 because it'll make this smaller for us, smaller numbers to deal with. So reminder here on quadratic formula, it's ax squared plus bx plus c. A is 1, b is minus 2, c is 2, like that. You could do it from the 4, minus 8, and 8, but the numbers, when you can factor out this 4, these numbers are better to work with in the quadratic formula.
Yeah.
All right, so we got x equals minus b plus or minus square root of b squared minus 4ac all over 2a, and we just put these numbers in. Now I recommend substituting in parentheses, even for positives, just to avoid any sign errors. Because that's where most of the mistakes are made, or just sign errors.
In the solution, he just set it equal to 0 and solved it. But I don't know if that's like harder or what.
When you say that the this part equal to 0,
Yeah.
right?
then,
And that's
like-
what we're doing. That's what we're doing here. I'm not
Oh,
what I'm sort of curious because the only way to solve this is through, well, you could complete the square, I guess, but you're generally looking at, most students prefer quadratic formula.
okay, yeah.
Is there if that wasn't sufficient, I mean, I can clarify, or I want to make sure you know why we're doing this. Like, why are we doing quadratic formula here? This one, hopefully getting across to you.
No, yeah. I understand that.
Okay, great. All right. So the part under the root is the most challenging for most students. So we'll just focus there. Minus 2 squared is 4. Minus 4 times 1 times 2 is 8. So under the root, it becomes plus or minus the square root of -4 over 2, like this. Do you remember how to reduce the square root of -4?
You can take out like something like, I don't know, like 2, and then leave it as I.
So the square root of 4, though, is known. And if you multiply it by -1, you can break that apart. And that's where the I comes from. The I comes from this square root of -1, but the square root of 4 is a known value. What?
Yeah.
And that's 2. So this whole thing is 2I all over 2. Okay, we're almost there. And then you have to divide each of these by 2. So it's 2 over 2, 2I over 2, 1 plus or minus I.
Okay, got it.
So there we go. We've got them all. Remember, it was it's way up here. It was a 3rd degree polynomial. There's 3 solutions. There's a real one at 3/4. So the real one is 3/4. The complex ones, or the non-real ones, are 1 plus I, 1 minus I.
Okay, got it.
Do you feel like you could reproduce this on your own?
Yeah.
Good. That's great to hear. Okay, number 12. In some ways, these are all kind of the same, so I guess we'll just keep going in order. I don't see like anything different, really. What's the asterisk next to the problem number for, if you don't mind sharing?
I think that means that like you can use a calculator on those problems, or like use Desmos.
Got it. Okay. Now, do you have Desmos up on your side?
Not yet.
Okay. Would you mind graphing this one and telling me one real root?
The only one was -1.
Yes. So let's write all the possible ones out. Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And believe it or not, there are instructors out there that make students guess these roots. So I mean, it's be very frustrating if I were a student that was the case. All right, so we write the coefficients down. Just a side note, I guess, is if one of the degree and if one of the exponents isn't there, like let's say there was no 4x, you still have to include a coefficient there,
Yeah.
typically 0. We haven't seen that yet, but something to think about. So bring the 1 down. 1 times -1 is -1. Add them up, multiply by 1, -1, sorry. So that's 6. 4 plus 6 is 10. 10 times -1 is -10. 0. So the power here is that this was a cubic. Now it's a quadratic. You can solve this always. You can always solve a quadratic.
Yeah.
Okay. So this is quadratic formula. A equals 1, B equals -6, C equals 10. I'll write it this time here. Minus B plus or minus the square root of B squared minus 4AC all over 2A. So will you do just the part in the root here for me, please? Tell me what you come up with.
Okay. Can you also do completing the square with this one?
Yes. Do you prefer that?
Yeah, that's just more like what we've done in class.
Okay. All right. So when you complete the square, you move this 10 over. And you're trying to figure out now what goes over here and what goes here. How are you figuring that out?
Like with the X thing, where like you see like what multiplies to 10 and adds to 6.
Okay, so that's not completing the square. That's
Oh,
a factoring, but this one doesn't factor nicely.
okay. Never
So,
mind.
okay, so we back to quadratic formula?
Yeah.
Okay.
Sorry, I was just confused.
It does work. It's just that this quadratic formula seems to be what most students go to. So again, just if you don't mind, if you could just do the part under the square root here and tell me what you come up with, just to see, you know, any sign errors or something. It does work out somewhat okay, I suppose. Do you have something for me for what's under the root there?
I got like a 3, and then I got a -2. Yeah,
Okay,
like
so just be clear, you're putting -6 in for B, A is 1 and C is 10. Like this is what I'm asking you to simplify, just this.
oh yeah,
What does that become?
-4.
Yes. Okay, because again, and this kind of works out nice. Like it's -6 plus or minus the square root of -4 over 2 times 1. So this is 6 plus or minus the square root of -4 over 2.
Yeah,
It's
I
a
got
lot
that.
like the last one. Could you take it from here? If you need to, maybe look back at your notes from the previous one.
Yeah. So is it 3 plus I and 3 minus I?
Yes. And then the other one was -1. There's your Your
Yeah.
four roots. Awesome. Okay. So we're up to 13a.
Mm-hmm.
So really kind of a repeat of everything we've been doing. They don't make you find all the roots, possible roots this time. They're just giving you that it's a 0. So that goes in the box. Coefficients of 3, -8, +1 and 2. So you just use your typical synthetic division. Bring down the 3, multiply by what's in the box, the 2/3, that's 2. Add vertically, multiply again, add vertically, multiply again, and you should get a 0.
Got it.
All right, so part B here is, it kind of relates to part A. If you set 3x minus 2 equal to 0, that's what becomes x equals 2/3. Okay,
Mhm.
now that's not what they're asking for, but I want you to see the relationship between the 0 and the factor, in case that's, something that you might see. Now the polynomial up here, they're saying it can be rewritten as a product of its factors. So the 3x minus 2 is given, and then you bring down these other ones. So that's 3x squared minus 6x minus 3, like that. And now my question for you is, because it's really unclear by the way this is written, is do we need to further factor? Like, just so happens there's a GCF in this.
Yeah.
It's kind of unclear the way it's written, I'll just say. So there's a 3 that comes out, that's x squared minus 2x minus 1. And then you can put the 3x minus 2 here. And that would be the other way to write this. This does not factor in here.
And then in the solution, apparently he multiplied the 3 into the, oh, never mind.
Like this up here.
Yeah.
It's very unclear. And sometimes I go too far on these because I look at these differently than a lot of people, but I want you to give the instructor what he wants so you can get the grade that you want on this.
Yeah. But in the solution, the 3 disappears. I don't know how the 3 goes away.
Yeah, not it's either the top one or the bottom one. Can't disappear. Let me just look at this one more time. Yep, 3x squared minus 6x minus 3. All right. If it would help, you can always send over the solutions to look at as part of this, but I can move on to 14a unless you have some more thoughts on this one.
No. I'll just like ask him about it in the morning. So I
Sounds
feel
good.
like I think he also did it differently. So I don't know. But we can just move on.
Okay. All right, so given the polynomial function, you have to list all the possible rational roots. That's the P and the Q business here. So P is 5, Q is 6. The factors of 5 are 1 and 5. For Q, it's 1, 2, 3, and 6. And then you just write all the combinations. So you've got 1 over 1 is 1, 1 over 2 is 1/2, 1 over 3 is 1/3, 1 over 6 is 1/6. Then you go with the other number on top here, 5 over each of these. So 5 over 1, 5, 5 over 2, 5 over 3, 5 over 6.
Okay.
So if you got Desmos up, maybe just graph this here, see what you come up with for your rational root here.
I got a negative 2.5, a negative 1, and a positive 0.33.
Okay, so how about that last one there? What would that last one be as a fraction?
I don't know, but I think for those ones we can use calculators.
You can, but the issue is that, like, it's a small, to you it doesn't probably doesn't seem like a big difference, but it's a huge difference in terms of like how you present your answer. You may want to just do a quick review. 0.3 repeating, 0.6 repeating. A couple of these are worth knowing, 1/3 and 2/3, like that,
Okay.
among others there. All right, so that's part B. The next part is a little bit awkward, especially with the fractions here and the decimals, because you don't write it. What you don't write, even though this might seem correct, is x minus 2.5, x minus -1, and x minus 1/3. Only the middle one is okay. This one's okay. The oddity of this is that you don't write it decimals or fractions like this. So for the minus 2.5, you actually have to write that as x equals -5/2, like this. -5/2 is minus 2.5.
Mm-hmm.
And then you clear the fraction. So you multiply both sides by 2. 2x equals -5. Then you add 5 to both sides to get 2x plus 5. So fortunately, this is not okay. This is good. That's what they want. The middle one is okay. That's x plus 1. 2 negatives become a positive. This last one here, and that's why that whole, figuring out the fraction is so important, because you can't write it as a decimal. So just like in the one on the left there, we're going to multiply both sides by 3 to clear the fraction. 3x equals 1. Subtract 1 from both sides. 3x minus 1. So these are your CRS's product of factors. That's your product of factors there.
Okay.
All right. Well, good news is I think we got everything done, and we did kind of just run out of time here. Less than a minute left. If you have time, be great for you to look at this.